Hello, everyone, and welcome to our session today with George. We know each other for a few years now, George. We are in the same
Yeah.
space, and it's always a pleasure to talk to you in different topics about different topics: infrastructure, cloud, agents, AI. So, for those who don't know you, so George is one of the brilliant guys I personally met, and I'm honest about it in different ways. So you have been building software for more than 12 years, if I remember correctly. And in the AI space and AI agent, at least the last 3 years, where you built Stackback. And yeah, let you complete the introduction. But today we'll be talking about agents in the infrastructure and the infrastructure. And I believe it will be exciting.
Yeah, I'm super excited. I mean, thanks for having me. Like Shafiq has been super helpful. Yeah, since we met. Yeah, he gave me a lot of tips as like a first-time founder trying to build an AI dev tool in a super crowded space now. Like there are a lot of
100%.
AI dev tools now coming out. So yeah, it was very like yeah, when I reached out, like he was super helpful to help me out like with a lot of founder tips. So yeah, I'm grateful and thanks for having me. Yeah,
My pleasure.
so yeah, we sort of like accidentally, like sort of like Forrest Gump, got into AI. The plan was to try make building like internal developer platforms and making infrastructure much easier for regular everyday developers using like fully deterministic tools. And yeah, that was like this is a super complicated problem to solve. And then when we started experimenting with LLMs in 2023, we found out, okay, like there might be something there. But yeah, then we discovered that LLMs were pretty bad at infrastructure. So we spent a year working on that, 2024. And then we found, okay, like this is not enough. Like even if they can generate like really high quality configurations, this is not enough to do what developers would expect them to do. Because like if you look at this statistically, like only 3% of developers know enough about infrastructure to work on it full time, which is very little. Like it explains a lot why people are always trying to hire DevOps engineers and they can't find anyone. Um, that's
Yeah,
what, yeah, that's like a main reason I loved Brainboard initially, because it's sort of like the most elegant way to edit infrastructure if you're not familiar with what's going on, because it's easy to discover like the building blocks, put it together like Legos, and then like apply stuff. So that was really fun about Brainboard. Um, yeah, so then we tried like bridging the gap, like trying to make like the normal engineer who knows nothing about cloud engineering, the resources, nothing about AWS, be able to deploy and manage their applications. So we got into agents. Yeah, and it's a black hole.
yeah, and this is where things get interesting
Yeah, this
because
got interesting. Yeah.
yeah, you're building, we are both building technical product for technical
Mm,
people. So everything we do is technical, and our population sometimes is picky about the technology, about the choices, about what's going on behind the scenes, about everything.
mm.
It's not just, give me a tool and let me use it, but I want to understand what's inside and the under the hood. And so to get started, so the first, maybe we try to peel the onion. We go layer by layer, like from agents into complete, maybe fleet of agents and how it works in the enterprise workload. So from your perspective, when you look into the LLM and AI in general apply to the infrastructure. So what's the first insight that you see?
Okay, so the main problem now is like the, as you said, like it's a tough crowd, like people trying to use agents, especially in infrastructure people like us. And we made an impression very early on that LLMs were terrible at infrastructure, and this was the case in 2024. But the thing
I
is,
agree.
it's changing. So I had this, like there was this study early in 24. I used to use this as a reference a lot, that tried to explain why LLMs are bad at infrastructure configurations and at creating like HCL, like Terraform code. And the main reason was like they picked a data set out of Stack Overflow and tried evaluating LLMs on different languages. At the same time, they hid the latest knowledge from Stack Overflow, and like they split the data set into two portions, like very fresh questions and older questions. And they found that LLMs, like as you would expect, like they perform best at TypeScript and Python because they're very popular languages in the training data sets. And they perform the best at older questions of Stack Overflow, which are also part of the training data set. But if you look at like fresh questions and languages that are not as popular, like HCL and Terraform code, they perform the worst. And in infrastructure, you have like the intersection of both. Like you have very fresh schemas and APIs that keep changing all the time. I mean, if you're following the AWS Terraform provider, they get an update every 4 or 5 days because there are thousands of resources, and the API providers like AWS and Google Cloud, they're changing the API all the time. So you have something that's changing frequently. At the same time, it's not a popular language. So this is like the weakest spot to put an LLM in. And this was the case until LLMs got much smarter and until you got agents that can try multiple times. Because back then we just like try zero shot, like ask ChatGPT to spit up some Terraform code and then take it and apply it. And you were doing that as well, like at Brainboard. And by time this started getting easier, especially if you put in like documentation, you give it the ability to search documentation, it got like much better. So most of the techniques we used to apply in 2024 to force it to like output the right syntax is not valid anymore, because now they can just iterate and fix stuff, or they actually got smarter or like bigger.
This is interesting. Yeah, this is very interesting because you described there are two states. There is a state where before we were try until you get it right, and you either teach the LLM or feed it with documentation or whatever the optimization that you do on your side as a provider of the tool. And so what exactly changed that actually made the LLM from the first try can give you a valid code that you can use right away without any optimization?
Yeah, so when we met at New York, like the first time, I was giving a talk about like how to make a lot of techniques on making LLMs better at domain-specific languages. And some of these techniques were just like describing to the LLM how the language works, like adding the grammar, for example, giving it more examples, or there are more deterministic techniques like bounded decoding. These you could already use in 2024 to make them generate better code. What happened is the models got smarter at figuring out, like they got better at coding. And if you're better at coding in Rust, for example, you'd be better at coding in general, like in other languages as well. So they just got smarter at coding, but they also got much better at retrieving languages, because back in 2024, having a web research agent built into your coding agent was not popular. Like this was not something like you had in all the coding tools. Like GitHub Copilot didn't do that back then. So the people like us, like Brainboard and Stackpack, where we added this like documentation indexing to feed it the knowledge, got like a much better performance, like almost 100% success rate with the iterations. Now that's built into every single coding agent. Like every coding agent has a feature that allows it to Google stuff or like look up documentation. So even if the LLM itself is still not good at HCL out of the box, the weights got bigger. So you got more weights, so you got more knowledge like baked into the model itself. But you also, all the harnesses or all the agents, the tools that trigger the models, they have more capabilities to look up information online, which made it pretty easy for the LLMs to get the information they need to iterate better.
Yeah, and interesting. And so, but the way I see engineers work today, I believe, and maybe this is unbiased because of what I see around me, that the code, the generation of the code itself, I mean, generating Terraform code itself, is not the main goal, because now this problem is solved. Yeah, and okay, you can, with a prompt, you can get a complete Terraform code, but if you don't know what to do, you still don't know what to do. So you are creating the infrastructure, but you don't know how the pieces are tied together. So I'm interested to know your insight about what are the verticals that you think or you see that agents and LLM can really help DevOps and cloud engineers.
Yeah, so like I double down, like I like thumbs up to your comment, because like this is exactly what we saw as we're building the product. Like we were focused initially on just generating infrastructure configuration, but then we found out like that all users trying to do this, like at least adventurous users that were trying to use LLMs in infrastructure initially in 2024, that they want to do stuff outside. Like you can generate Terraform code that works 100% of the time, but then when you apply it, you get some API limit in AWS. You get some weird error you didn't expect. You actually need to do some like state plumbing to figure out like how to migrate this module or like how to change a parameter without breaking production. So there's a lot of things around infrastructure as code. That's why it's not enough to be able to create PRs with infrastructure as code. It's not that helpful. It's really good at it, but like you can create a PR and then can try apply it and then fail. So you need this glue around infrastructure as code that can iterate, can run commands with like cloud provider CLIs to be able to make changes. I actually pulled some data about your question, so I can share this quickly.
I love
so
the
this
data.
is just like the past. Whoa. Yeah. So this is some data from like the past 2 weeks, like from like just anonymized metrics from our users. So our product is actually like an open source agent for infrastructure. So it does infrastructure work. You'd see here like people use it for containerization, for creating CI/CD from scratch, from writing infrastructure as code, from troubleshooting, security, and network. So like everything. And this is already like what's been happening like just the past 2 weeks. So like whether we like it or not, like people are already using agents, and like coding agents now, like Cursor or Claude Code or Droid or whatever Warp, like regardless of the agent you're using, developers are already trying to solve infrastructure problems with agents. And most of these tools, we still like, people haven't invested a lot in the security of the infrastructure surrounding these coding agents. But people are already attempting to solve these problems. And you'd see like have you heard of, I mean, it's going on fire now, like the Cursor incident yesterday, where Cursor like created a curl request to Railway to delete the database with a post request. So this is something like, at least at Stackpack, we know how to prevent this like from a year ago. Like we launched something a year ago that can prevent this. But like if you look at the coding agents, there are 30, 40 coding agents in the market now. And not a lot of effort is being put into how to like secure this properly in the threat model of using them to run the infrastructure. But developers are already using them in infrastructure.
But if we step, if we step back, that's I mean what I'm interested in, like the definition of the agent itself, because so like if you give us just an overview of or the anatomy of an agent, is it just calling the LLM? Is it calling the LLM with tools? Something like that. Is it how to feed it our own data? Does it have access to the state? Because this is like a very sensitive information there. So if you give us like an overview of how
so meet Norbert. So Norbert is the name of like the naked minion, and this is like how we sort of like defined an agent internally. So the very first agent we built at Stackpack was November 24. So like it was very vague. I think still now, like it's very vague what a harness is. And so now an agent became a harness, and harness has like 1,000 definitions. I literally like I dispatched a Claude deep research agent to summarize whatever everyone means when they say harness. They're like 4 or 5 different definitions. But like at the core, the most basic thing, Norbert, like I can tell you about this story. So the first agent we built was actually an agent that had like a single tool, which is running a bash command. That's it. And
I do remember, I think I tested the first versions of Stackpack.
Yeah, I think I showed it to you. So the agent is basically something that thinks, which like in classic AI, this used to be like rules or like a policy that you train with reinforcement learning, for example. So it thinks, it has a set of actions it can decide from. So it can, like, for example, like run a bash command with a specific parameter that specifies these commands. It can ask a user questions, like the first agent we built that we called Norbert. And then you apply these actions in the external world, then it observes the effect of this action and iterate on a loop until it just achieves some end goal. Whoa, what happened?
Yeah, your sharing disappeared.
Yeah, it dropped. Yeah, here it is again. Okay. Yeah. So you can define an agent like like an agent has 3 things. It can take actions, and it has the autonomy to choose which action to take at every point in time. It iterates, so it takes actions. These actions affect the external world, and then you map the state somehow so you can observe it. And it keeps going until it reaches an end goal. So that's the most basic definition of an agent. So thinking here is done with an LLM, which is what changed when how we built agents with generative AI. The actions are like the tools we specify. So you can have built-in tools like editing files, or you can add MCP servers, which add more tools. So it gives it more options to take actions. And there's the agent loop, which keeps iterating. So that's why it can do really crazy things with very simple primitives like file editing tool.
Yeah, and so apply to the infrastructure. To the infrastructure, which is like a specific domain. I'm more interested into the input and the actions. So for like talking about the input, what do you see like as input to the LLM today or to the agents today?
Yeah. So initially, this was just a prompt. That's what people call prompt engineering. But then it evolved into like you also include external information, like what we mentioned, documentation. Like if you wanted to generate configurations for an AKS cluster, it has to read the AKS documentation. So this is documentation snippets. But you also have like reusable internal knowledge or like SOPs, like standard operating procedures of how you operate. When we ran an experiment, like an evaluation on agent Dockerizing applications in January 2025, we found out for some reason LLMs were really bad at Dockerizing PHP applications. So the way we found out how to solve this, there was a paper called SOP Agent, and you add just like very high level instructions on how you'd approach Dockerizing a PHP application. You can never create instructions for every single application because there are a lot of different dependencies, a lot of different like details in how you can build like a lot of different ways you can build a PHP application. But like these high level guidelines, when we added them to the agent, the success rate went up from 0% to 100%. So this is exactly what skills are. Like there are distilled operational knowledge that are high level, they're generalizable, they're not very specific, that the agent can also copy or like look into as a cheat sheet to be able to approach something. Like we call this in operations like runbooks. You create a runbook once on how to do something, but then an engineer who's a human who's smart can take this runbook and customize it based on whatever incident they're handling at the moment. So it's not generalizable. So the input can be a prompt, can be documentation sources, can be also curated knowledge that the engineers build to teach the agent how to do things in a more efficient way. And so these are all kind of inputs. So then it evolved from prompt engineering to context engineering. And now they call it harness engineering because you don't just like shove in a lot of information, but you also have to keep other information out because like us, like we have a field of view, we can see a specific like angle all around us. And the more crowded this view is, the more details there are, like the find Waldo game, the harder it is for us to do it, like to function properly. So this is exactly what we call a context window for the LLM. They have like a limited peripheral vision, and the more stuff you stuff inside, the more crazy they will go. So you would see models with like 1 million token context window that can fit like millions of millions of characters, like entire books inside. But research found that actually agents start losing focus starting 20 or 30,000 tokens. So way, way earlier than like hitting even half of the available token, like context size. So that's why the harness actively removes some of this context and adds stuff based on the task in the goal of helping the agent achieve the end goal. So you keep messing up with what is observable. For example, like if you run a Terraform plan command and the plan is like 50 pages long, the harness can dump it into a file, show the agent just part of it, and ask the agent, okay, if you want to read more, you can just paginate or like look into specific lines to keep this crisp enough so it can achieve the end goal. So this is the goal of like context engineering and now harness engineering is to how to engineer the agent in a way to keep it like to give it the information it needs at the time it needs and remove anything else unnecessarily because you want to stay focused.
You see, yeah. And so as an engineer, for example, if today I want to build an agent myself, like let's say I'm a DevOps engineer working with a team of 5-6 people, and we are interested into the space and we want to build our,
yeah, I think like we never, like I never shared this, like I pulled this, like it's an old presentation I gave. And yeah, surprisingly, you're asking the right questions. Right.
I like it.
Yeah. All right. It takes only 300 lines of code to build an agent, and like 100 lines of them are just the system prompt. And actually, like I have actually a tutorial on GitHub with reference code to show you like how to do this with 0 dependencies. So like anyone can build an agent. Yeah, here. Can you please add my screen on stage? Yeah, okay. Yeah, so that's it. Like you need to define like how it thinks, like the thinking prompt, create the loop that keeps like taking like running tools, taking the output and then feeding it back, and then the actual tools like file editing and so on. And you can have like a working coding agent, 300 lines of code. The clever or like the engineering part comes in like on what exactly information to keep and what information to throw out at any single point of time. And security is like when to let the agent ask you for permission and when to let it run it autonomously. And I think this is one of the biggest problems now in using agents in infrastructure, like where to draw the line between agent autonomy, like OpenClaw, that can do anything on a loop, and when it should actually ask you, because you want this to be like 100% deterministic. So the agents are useful because they're not deterministic, but you want the permissions to be deterministic. So this is the challenging part.
And the permission for me as well, there is two parts. There is like the work to be done, and there is the actions to perform. Like for example, I'm looking at it through the lenses of the cloud infrastructure. So what I think about when I think about it is like, okay, I have agents that may help me troubleshoot, for example, failed Terraform plan, help me troubleshoot an infrastructure that is not working correctly. But do I give the agent the permission to do the actions like changing my infrastructure, doing apply and destroy?
Yes.
Recreating resources, destroying the database, recreating the database, or so like two parts. Or I should approve and what I need to approve, and so on, how I can combine the agent with human in the loop to be able to have a smooth process without having the human to be still the bottleneck.
Yes. This is like an open problem we're trying to solve. How we do this initially, like with people trying to adopt agents in infrastructures, we do it on phases. Like we start out, every single action has to be approved. And then they start like whitelisting permissions one by one until they trust the agent more. There are multiple layers to this. There are some mechanisms we added like in the open source agent that helps you have like the safety net. But you also have to define permissions properly. I think the new thing here is it's exactly the same problem you have with people. Like you have to define roles and their permissions. If you give them too much permissions, then you have like a scope creep and the permissions just keep growing. If you gave them too little permissions, they wouldn't be able to do their jobs. The problem with agents is that instead of having like 10, 20 people, you have like thousands of them doing very specific tasks. So the permission problem is exacerbated, like it's more complicated, but it's exactly the same issue we had with people.
100%, yeah. And so one of the guys in the chat asked for the link. He said Sharif An-Nabawi said, share the link, please, George. I think the link to your repo, I guess, or to your
yes,
both repo or presentation. Yeah.
I think the repo here. So let me. Yeah. Okay, I can join the chat. So I can share the link here with you. So this has the code sample on how to build an agent like in 300 lines in Python with just like OpenAPI dependency. There are also frameworks now you can use to make this easier. But yeah, this has like slides describing like how to build an agent and a code sample you can use that we can share. There's also actually like, I think this is also might be useful and relevant to what happened yesterday at Cursor. So this is a blog post. I'm trying to like a threat model running agents in infrastructure. Like what can go wrong if you let an agent run your infrastructure, even if you have like if you gave it root access. We share here like everything we explored over the past year, like different approaches, and this keeps changing because some of the approaches still work today, but some of the approaches, the smarter models found intelligent workarounds. So for example, like we want agents to work with secrets because it's infrastructure. Like you want an agent to be able to rotate the secret. So we used to do secret substitution. So instead of having, I think I have this in a slide here somewhere. Yeah, I think it's this one. Okay. Yeah. So this is the threat model, but let me skip that to get to the secret injection proxy. Yeah. So what we did here is we let the agent work with secrets, and then we use the git leaks secret rule set to substitute secrets with placeholders, and then feed the agent these placeholders and replace them again. So the agent is able to compare secrets because they have this table IDs that map to a specific value, and it knows what the secret type is, but doesn't know the actual secret. So this worked for a year until Opus 4.5. If you push Opus 4.5 hard enough, it can do like a TCP dump, like a hex dump of the files to rearrange the characters vertically so they wouldn't hit the Git leaks rule set. So some of the security mechanisms you're sure sometimes works. Smarter model will find a way about this, a way around them eventually. But like other parts are like hard and tested. So we have other mechanisms to prevent them from running like destructive commands. And this one is actually like the agents are not easily able to bypass unless they find some 0-day at kernel level that they can exploit. So that's the scary part about this. And it sort of feels like you're building a cryptographic algorithm where the algorithm has to stand against time of people trying to like breach it for a while, like hack it for a while, until you're sure that this is actually useful and like it's preventing the agent from destroying things.
And so, and also I have like, I'm doing a devil's advocate here, just to push the thinking process. So what's the difference between building an agent and or having a cloud like Claude with some tools that they can run locally? It can run locally, and having access to my information that stays local, and that I can control the execution. I can say, all right, you can access this file, you don't access this file, you can do that, you can do that, versus I have an agent, let's say, out of the box tool that I use.
Yeah, I think you should definitely not build your own agent. Like, you can customize a lot of, like, you should be aware of this, like the security model, what you can accept and what you can accept. And the agent harnesses, like a harness is what people say when they mean like an agent implementation. So Claude Code is a harness, and Open Code is a harness, StackPack is a harness. So you can use the same model with all these different harnesses, but every harness has specific features that are fine-tuned for specific tasks or have a different security model. So for example, this is the security threat model we used when we built the agent because it's optimized for infrastructure. This is completely different from a threat model developed for a coding agent. So for a coding agent, everything that can go wrong is usually happening locally. So you can change like break code locally. But in infrastructure, it's usually a network request. So you do Terraform destroy or use a CLI to apply something and destroy something remotely. So the threat model is different. So although it's like they have the same tools and they all use the same model, there are slight differences in the model. So or in the threat model and how the tools are built. So that's the main difference. There are some very flexible harnesses like Pi where you can like create extensions instead of like coding the whole thing yourself. So you're sure how each component is working, and it's open source as well, which allows you like to see the code, like be able to extend stuff or modify things if you want. But I wouldn't recommend you build your harness because there's a lot of work involved in actually making it useful in your company that you just don't need to code this and then do the extra work. So you will see here like if you want to talk about like how platform engineering looks like now, this is a very fun subject because it's instead of people building custom React components in Backstage, you're now creating knowledge. So you're just like creating markdown files. You're not coding anymore. You're creating markdown files. You're fine-tuning how your agents work by just like adding better skills, better prompts, instead of actually coding interfaces and coding automation, because they're really good at creating automation. In my own workflow, I do something once, and then I ask the agent to inspect its own session and then create workflows that would automate this forever. And then instead of the agent doing the thing itself again, I would let it just like trigger the workflow to run this for it. Like it's automated forever. Like it's much cheaper now to write automations.
Yeah, and I go back to the topic, to the security thing, because it's very interesting. I remember when we were talking like the areas where we are exposed when we use agents or LLM, especially for the infrastructure. The first one, there is like the sensitive data and the data leakage, including the secrets, the API keys, maybe the certificates, and so on. And especially when you build the infrastructure, you may have a chain of configuration where at some point you need to manipulate these sensitive information.
Yes.
The second one is the configuration corruption. and like at what point the LLM is counterproductive, the agent is counterproductive and corrupt in its own maybe what it has built before. And the third topic as well is what we talked about is unauthorized destructive actions, like destroying the database or doing any action, unwanted action. So how do you see these three verticals working together in terms of security, and what could be the best configuration to mitigate this?
Yeah, so I can tell you what we tried and like the approaches that worked well. So for secrets, I told you about like secret substitution.
Yes.
There are also other interesting approaches. So, so we found in secret substitution specifically, like there are now injection proxies that you can use. So the secret actually never gets exposed to the agent. You do everything through like on the network request itself. You'll see a lot of implementations of this. I think this is the best approach you can now use to let agents handle secrets. But we also found a big limitation in the secret detection rules of Git leaks. Like sometimes it's not straightforward to detect the secrets this way. You need something smarter. Like in FastForge, they used language models to harder to detect secrets, but then this is counterproductive because you're selling the secret to the LLM. So I see someone like trying to like fine-tune local models to be able to do this offline, then it would be much more useful to detect the secrets. So even if you don't inject them and the agent gets a secret, it still wouldn't be able to see it. So there's a lot to do here. But I think if you're going to do this, you would need to look for a secret injection proxy or a substitution mechanism like the one exists in Stackpack. You would see this pattern like in every single threat. Like most of the time, the solution is not prompting. The solution is adding some engineering layer that works 100% of the time to prevent this from breaking.
Predictable.
Yeah, so for breaking configurations, there are a lot of things you can do. The one we settled for now is like making all file system operations reversible with backups, so you can be able to restore even if you don't have backups. So this is what's implemented in like the open source tools we have on GitHub. But there's also a better approach I started working on recently, which is Bento. You find this on my private GitHub repo. So what Bento does, it like sort of like wraps up all the configurations the agent is editing into OCI artifacts and backs it up in an OCI registry, so you can recover it, regardless of whether you're working on Windows, like Mac or Linux. It's still very early, only me using it so far, but there are like interesting approaches people are using, even if you don't have backup enabled to back up your configurations, or you don't have something codified as infrastructure as code. There are also some things like agent FS. If you're using an agent and you let it use agent FS, which is also experimental, it adds this virtualization layer between your file system operations and the real file system. So everything is stored in an SQLite database, not persisted directly. So you have this layer of like you can revert any change because everything is stored. So this is just like the agent itself never has access to the actual external world. It has to go through something. And if you inject something in the middle, like you would see here in the threat model, this is very obvious. Like there is, like the agent is blocked here. It accesses your resources only through tools. We never got through this, but like I never described this, but you have the agent, which is like the brain that talks to the LLM and takes user input, but you also have the tools, which is its hands, like doing things. And it has to go through your local OS stack to access the file system or the network. So even if it's making like a remote change, it has to go through the network first before hitting an API. That's why I say like if you add your protection here, you would prevent it from breaking things because it can't take actions on its own. Like LLMs need help from the harness to be able to affect the external world. So that's how we do like protect you from breaking configurations or like leaking data. The third one, which is the most interesting, is like modifying external resources. So this is the one that is like underexplored and hasn't been a lot of effort put into this. The first thing that comes to mind, or like I see infrastructure people proposing, is like just give it least privilege. And yeah, this sounds like something you have to do, but like we've been failing to do this for years now. Like it's very hard to keep like access scope down, especially if you have mission-driven agents doing something very specific, and you need to create their access on the fly. So this doesn't work in practice. Like people can't get this to work in practice, specifically with agents. It's easier with humans because, like, a human has a specific role, but for agents, they're mission driven. So the role keeps changing all the time. So this is very difficult to do in practice. Another
Yeah,
thing,
yeah, go ahead. Yeah, that's interesting because I think we implemented in Brainboard somehow the same mechanism. I will talk about it. That's very interesting.
Yeah, you should talk about it now. Like, I would love to hear about what you did.
Yeah, so actually it's the same 3 areas of exposure, and we implemented kind of mechanisms to for every step. So the first one, which is the broken configuration, we take snapshots. So for example, let me check. Let me show you this. All right. So for example, here I have this AWS architecture, which is Dashcom. It's for video recording and analyzing the videos and so on. So when you use the LLM in Brainboard, so whatever you ask, it takes snapshots of the actual infrastructure that you can revert. So we have the versions in Brainboard. So here I can create a version for whatever I'm doing. This is the normal way the developers or DevOps people do when you build cloud infrastructure. When you push to Git, you create a version. We wanted to have the same mechanism for the agents. So for the agent, when it works, it takes a snapshot of the configuration before the change that you can revert to in case it's broken. The second part, which is the sensitive information, we first, we do not give it access to the Terraform state because sometimes in the diagram, you are not representing the secret. You are not hard coding the secret, but you are given the reference to where this secret can be accessed through the data blocks. But when you run the Terraform actually fetches the secret and keep it in the state. So if you give this to the agent has access to the state, to the secret. So we do not give it access to the state, which is the second point that you mentioned. And the third one about the privilege, we actually the agent cannot do an apply and destroy. So it can, for example, here I ask it, is the plan valid? So it will execute the action that you will see here. It will, based on the recent Terraform, I can trigger a new one. So it helps me troubleshoot. It will execute actions and it helps me troubleshoot and fix all the errors, but it will not do. It will not change the infrastructure. So that's the privilege that we put around that only the human can do the apply and destroy. And only the human has the keys actually to change in the infrastructure physically.
Yes. What we're trying to challenge now is like how far can you push this? Like how much autonomy can you give the agent and still be safe? So even if you wanted to be able to apply, like how can you be able like either recover from this failure or actually prevent it from growing? Because, for example, like if you give an agent an ability to apply Terraform code, it can give itself more permissions by like doing privilege escalation, by modifying its IAM role. And LLMs, we found them are very good at exploiting issues. So like how can you prevent these kind of like privilege escalation if you want them to have more autonomy? I think that's the open question.
Actually, what we did, for this part, we it's our backend that actually validate the action, not the LLM.
Yes.
So only the backend can do the apply and destroy, and our backend is a code that the team wrote, and it's predictable and has all the checks, and you can see here, I'm not able to trigger the plan and find a work around to run to provision. So even if you ask it, so it's like we removed the keys physically from being able to turn on the engine of the deployment. So there is no workaround available. The restriction apply and destroy operation is hard security boundary. So we put the hard boundary where in the backend, when we see the Terraform apply and destroy, the backend stops it. It's not the LLM that tease.
Yes, this is exactly like the pattern, like the pattern we kept finding repeatedly. Like you need something very deterministic to control security and access, and not rely on LLM. Like I have a very interesting example here. If you let me share this. So
Yes.
yeah, one of the very popular solutions, like we know blacklisting and whitelisting doesn't work. So the LLMs can
Yeah.
like if you block a command, you can just like write a Python script or
Yeah.
like edit the privilege somehow. So the interesting like thing we keep seeing is people keep suggesting using LLM filters. So have another model specifically trained to detect like destructive commands and prevent them. And you see like from much earlier, like in self-driving vehicles and like in any vision, like in any deep neural network, there's this like whole subfield called adversarial machine learning, where you can train another model that would be able to trick the parent model. So, for example, if you see here, this is image. I think it's ImageNet. Like it's one of the oldest neural networks that were actually useful. It classifies images based on classes. So here it can detect this is a cup, this is like a bassinet, this is a hamster, this is a teapot, based on the image. And what the researchers did here is they developed an adversarial network that would change a single pixel in the image to trick the model into misclassifying it. So here you would see like it, instead of classifying it as a hamster, it's classified it as a nipple because like a single pixel changed. And
Yeah.
this is like a theoretical limitation to deep neural networks. You can always find at least a single example that will be able to trick the classifier. And the same thing with self-driving vehicles. Like you can create this 3D printed object that will convince a specific neural network to just like take control over the vehicle to do something. So this is like a theoretical limitation. So you can never rely 100% on a model to prevent another model from doing something bad. This works, but not 100% of the time. So that's why we don't like any approach that relies on like machine learning to be able to do this. I lost my screen again. Okay, yeah, here it is. And the same thing with coding sandboxes, like what I mentioned earlier. Like if you're used to like there are 30 or 40 coding sandboxes. That's why like I created a project like indexing all of them and a taxonomy. And you see there's like a huge gap in the middle here when it comes to network policies and granularity of network policies and governance. And this is where agents break an infrastructure. They make a web request that breaks something, like exactly what happened with Railway. So you can't assume if it's a sandbox, then you'd be safe. Like it has to be a sandbox specifically designed for this specific use case because, yeah, like the threat model is completely different. You see, like they're all clustered on compute. It's tiny, but like I can tell you what's there.
Yeah, I can share the link as well. You can share it.
Yeah. So what worked for us and still works in production is using sort of like a reverse web application firewall, is trying to intercept all the traffic coming out of all the tools the agent is running, like the Terraform. So the agent can run Terraform apply, but when the Terraform apply is working and it's trying to modify an IAM resource, there are some policies being applied at the proxy that will prevent a specific IAM resource update web request from going out of the sandbox. So this makes sure that regardless of what tool the agent is using, we're able to intercept it at the lowest common denominator, which is the network traffic, and block the actual request that makes the change. So even if the agent like has access to all the tools, can write code, can run any CLI, has admin access, it still wouldn't be able to make the single web request that would break your infrastructure.
A quick question here. So at this layer, so what this proxy does it inspect all the network requests or network traffic, and based on what it determines whether the action is legitimate or not? So maybe I'm running from my laptop, I'm running the Terraform apply. So how does the proxy know that this is me running the Terraform apply versus an agent running Terraform apply?
Yeah. So this wraps the agent process. So here what it does, it spins up the agent inside a container and creates a sidecar with this container that proxies creates a network bottleneck to intercept all the traffic. So if you're applying it from your laptop, you didn't enable the sandbox, it would work fine. But if you enable the sandbox, then all the traffic is routed through a transparent proxy to trick all the CLI tools inside the container to route traffic to this proxy. And it also does TLS interception to be able to inspect the HTTP request details. And all of this is done locally. So like you wouldn't have to send unencrypted traffic like a long way. Like we try to make it stay as close as possible to where the agent is running. So you can actually start like 2 or 3 different agent instances Some of them are sandbox, some of them are not, depending on the task. So actually, this is how we do sub-agents. So we let the main agent dynamically create a sub-agent and decide whether to sandbox it or not. And if it doesn't sandbox the agent, then the user has to approve every single like tool or action it tries to make. And if it sandboxes it, then we're sure that it would never be able to do something destructive, so it gets more autonomy. So it's sort of like we're negotiating with the agent. Like you can get more autonomy if you run things safely, and you get less autonomy if you don't. And this allows you to do some cool things, like you can spin up 10s or 20 instances of the agents, and you would be certain 100% they would never make a destructive web request, regardless of what they decide to do inside the container. And you can parallelize things like codifying cloud infrastructure, like doing mass refactoring and a lot of cool things, just because you're certain they can't make a web request that would hurt your infrastructure. That's why I need this at the network level, because if this request leaves your machine, then yeah, they can do a lot of things.
Yeah.
And you asked about like how do you decide, and this is what the policy is. Like it's very hard to be able to do this like with a single implementation. You have to be able to customize it. We picked a policy language which AWS open sourced called Cedar, because it's super simple. Like you can have loops, for example. It's not like Rego. I've maintained a set of Rego policies, and like developers hate Rego.
Yeah, it's
so
really
this
complex.
makes it easy. Yeah, if you map this to just web requests, like an agent can read any web request, and this maps to like just like get options like read operations. But we also flatten the AWS requests to like the standardized format here. So you can add a policy that would allow any read operation to AWS, but would block any post operation by default, unless the actions are like described get search. So with a 30-line policy that looks this simple, you can prevent all destructive actions to all AWS resources without having to like be able to understand all the like add rules for every specific thing, because like it blocks everything by default, unless you whitelist the kind of actions like you want to pass through the proxy.
Okay, it makes sense. And so yeah, so the work the user works locally. He or she has this proxy locally as well to intercept the traffic before going out of their laptop, or
yes,
in case of automation, it runs in their pipeline as a sidecar as well, I guess. If
exactly.
Okay, and then I saw also another layer of network, and then it hits the cloud provider.
Yes, exactly. So even if you don't get the permissions of the cloud provider, right, you have this like defense in depth design. So you can button up the permissions, but even if you didn't, this policy would prevent the request from going out. That's why I call it like a web application firewall working in the other direction. Like it prevents requests from going out.
Okay.
And this is a much easier enforcement layer, because if you prevent the web requests or like the file directories you're writing to and so on, it's much easier than trying to get access to all the cloud accounts and like change the permissions in all the different cloud accounts. You still have to do this, but at least this is like an easier way, because you write the policies in the same language, and then you have like your traditional like least privilege policies on the cloud providers. I think there are some people working on making this easier. Like there's a founder, BetterAuth. They're building this like CLI. Like SDK for authentication, open source SDK for authentication. They're working on this agent auth protocol that allows agents to negotiate capabilities for API access they need, and then you can grant them these capabilities, or like that, like a token with a limited lifetime and a very limited scope to do the task, and then it gets revoked. So people are actively working on this for like third-party APIs, but this is like the layer we thought we're comfortable with, because like this was like more than a year ago.
Okay, yeah.
So there could be better solutions now people are working on.
100%. And so I know that I'm checking the time. I know that you have another meeting after in 10 minutes. So in the topics that T is remaining, so maybe if we can talk a little bit about the sub-agents. So we are talking about the agent as one thing, monolithic like execution. So how the sub-agents work together to actually provide a value, especially again in our context, which is cloud infrastructure, DevOps, and so on.
Yeah, so this is a very controversial topic because like a lot of people see this differently. So I'll tell you like our point of view. So like from our experience and the evaluations we ran like the past year, we rarely found sub agents to add something. So mostly sub agents were used for context compression, like to improve, like keep the agent running and stay crisp for long durations or complicated tasks. So for a long time we had sub agent supports, but we hid it behind a flag, so it wouldn't be enabled by default because like we thought it's useless. Like recently, the past couple of months, we found actually it's very interesting to have these sub agents being scoped down to specific pieces of work with specific access. So the main agent can spin up a sub agent that has only a read file permission. They can read files to synthesize the results. Because something also we learned is that the more tools you give to an agent, that's why like abusing MCP servers is a bad idea. The more tools you give an agent, the less performant they would become. So for example, like the AmpCode team just removed 3 tools because the model got smarter, because like every single harness designer knows this. Like the more tools you have, the worse the agent will perform. So being able to spin up a sub agent with a very limited tools, with very limited access to do a specific task is very efficient and it's much safer. So this is how we use sub agents now. Like we don't have an army of sub agents. We have a main agent that can dynamically spawn sub agents with very limited scope of work and very limited access. Access that's less than the main agent's access. So it can do privilege escalation to do a lot of things and then come back and synthesize the results. So what I'm seeing now in the market is people are going to this direction. Is like you make the agent capable of creating its own sub agents. They're not predefined. Like you don't create a testing agent and a coding agent and a review agent. You leave it to be very mission specific. So I'm creating this agent to specifically enumerate all my Kubernetes cluster on AWS, so I can find out if there are any like operators that need to be updated. So this is a very mission specific sub agent, and LLMs know how to prompt themselves really well. So they will write instructions for the sub agent much better than I would as a human. So we found this in practice to work really well, like letting the agent just create dynamic sub agents to do a specific task with specific permissions and get back to it allows it to be more autonomous, because even if the main agent can run commands or write files, if it asks me for access, it can spin up a sub agent that runs in a sandbox that can't write files and it would finish all its tasks autonomously and then return. So it bothers me less often and I'll still feel safe about like it being autonomous.
Yeah, I see. And so, thank you very much. I mean, a very interesting conversation. And I personally learn every time I talk to you, which is really great, and hope our audience as well is learning. So the last thing, what is the advice that you can give to someone who is, let's say, starting the journey of the agents or exploring for his team, her team, how the agent can help? So what's the piece of advice that these people can leverage?
So for yourself, there's a learning curve in learning how to use agents. So if as a DevOps engineer or platform engineer or infrastructure engineer, there is like, you need to learn how to use these agents because they can make it like it's a digital tool in your arsenal. And developers are already very comfortable with coding agents, but like infrastructure, people are still resisting, and you need to learn how to use them. It will take some time. Like one of my colleagues at Stackpack, like he's a brilliant engineer, but it took him a while to learn how to prompt LLMs. Then now he's unstoppable. Like he has an army of agents working for him. So it takes some time to learn. Yeah? So you need to learn, experiment with them. The other thing is like from platform engineering perspective, we're seeing that you need less and less platform. You need like the layer you're building to automate things in infrastructure is becoming thinner. So for example, instead of needing a Datadog integration, agents can use the Datadog CLI to respond to Datadog alerts and launch an investigation with a very simple setup. So I just created this like sandbox environment this morning with AKS clusters, Datadog, and a database that that has some lock that breaks things. And the agent is, by simply scanning the code, it can create customized alerts that run on a schedule and respond to Datadog alerts and starts an investigation and then reports back on Slack. Like I built this whole platform in an hour with very thin set of tools and just like our open source agent. And you can do this with other coding agents as well. But the idea is you need much less observability data. You need much less tool stack to be able to get something useful to operate your platform. So the way we're building platforms are going to change. And there's no standard way of doing this. You have to experiment. And that also means you have to start trying using this stuff in some experimental way internally.
When you mentioned Datadog, I was about to ask, do we need Datadog? Maybe we just use the raw data from the cloud providers, and that could maybe work better.
So at Stackpack, we're doing fine with CloudWatch and agents. So the agents write scripts in Python to automate some observability tasks, and they iterate based on Datadog, based on CloudWatch data, and that's it. We don't need fancy queries in dashboards anymore, because you can just build a dashboard with Streamlit from scratch. You can create your own alert automation on top of CloudWatch, which is ugly to use for humans, but agents don't mind. They can just get by pretty well.
100%. George, thank you very much for your time, and thank you for your insights. It's always great to talk to you. So we can schedule another session maybe to go deeper into any specific topic. Enjoy the rest of the day. And for everyone, thanks for joining, and see you in the next session.
Always fun talking to you, Shafiq. Bye.
Thanks, George. Goodbye.